And welcome to this session on CDK in complex environments. My colleague Hans Terval and I would like to share our experience working with several deployment methods over the past 3 years. We will talk about our environment, our evolution of approach, and the transition that we've been making this past year. So Hans and I both work for a team at Conclusion that has a dual responsibility of both supporting the platform that applications run on and supporting the DevOps teams that build and run those applications in an AWS environment. We are both DevOps engineers, but while I come from an ops background and have become more dev, Hans comes from a dev background and has become more ops. And what kind of environment are we working with? It's based on work that we've done with our client, Royal Floater Holland, the past 3 years, transforming their applications to an AWS environment. From a deployment standpoint, the technical environment is more than 100 applications with 450 components, 27 DevOps teams, hundreds of pipelines, deployed as infrastructure as code via fully automated CI/CD pipelines. From a deployment standpoint, one of the primary challenges in such a complex environment is maintaining consistency and standardization across so many different applications, while still providing flexibility for the DevOps teams to build innovative applications, and also invite contribution from those teams to further develop these techniques. This gives us then a familiar structure for CI/CD structure for deploying resources into multiple AWS accounts. Over these past 3 years, we've gone through an evolution in the way that we approach this. Being committed to infrastructure as code, we of course began with CloudFormation templates to deploy the landing zone and platform resources. And while that worked well for the landing zone, because there was one platform team that deployed those, that maintained those templates, we ran into some limitations when we wanted to support the DevOps teams. In particular, adapting templates from one use case to another often creates not only more and more templates, but becomes challenging because you copy snippets of a template from one to another, and you can get drift in your template technique over time. Also, maintaining a large collection of templates from multiple teams can be quite challenging to ensure that company standards, especially with naming or configuration, is maintained across multiple templates. And above all, CloudFormation is not the core business for application developers and administrators. They just want to build and maintain applications. So we've tried to address this standardization for them so they don't have to. And that to do that, we created what we called a blueprint. What does a blueprint look like? It is a CloudFormation template, but one that's been made generic and is stored in a central repository. Customization is then made possible by storing the parameters file in the applications repository, and then that blueprint repo is linked to each application's pipeline. We deploy then we've developed a blueprint per use case, and we deploy a CloudFormation stack per blueprint. We chose this approach instead of stack sets to give DevOps teams more control over the versions and updates of resources. And that gives us then a central repository linked to hundreds of pipelines. While this collection has grown as teams have used more and more AWS resources, it still has been manageable to provide this, to maintain this over time. And it has worked well for providing a great deal of standardization across multiple applications with multiple teams. But while it's worked well with ES and fairly simple serverless infrastructures, it has become challenging for more complex serverless and microservice architectures. That comes because when you have templates that have common components, such as for naming convention or configuration of common components, then it becomes very difficult to maintain that over time. When you make a change, you have to change it in multiple places. Also, while these templates do allow for a customization, so you can have an internal load balancer or external load balancer, when you have an undefined number of resources that you need for use cases like with microservices that can have multiple API gateways or lambdas or SQS queues, then it can be very challenging to create a template to account for this in multiple cases. And trying to get multiple teams to create templates in the same way to ensure a consistent naming convention or configuration is like herding cats. Above all, we also have a couple of Uber templates that have simply outgrown the limitations of CloudFormation. One is now 2,000 lines of YAML with 60 parameters and 55 resources, and is at the point that it either needs to be split up or redeveloped. So this brings us to CDK. My colleague will tell us more, will share more about what we've been doing with CDK, but it's clear that especially with serverless and microservices, we finally have found the flexibility that with CDK that we've been missing up to this point. And if we look at all three of these methods, then we see that CDK offers clear advantages for the reusability, the modularity, maintainability of these templates. And with that, I would like to hand it over to my colleague to share more about our transition from blueprints to CDK.
So thank you, Tim. That brings us to my part of the presentation, going from CloudFormation blueprints to CDK. The goal we're trying to achieve with CDK is that our team members do not have to be CloudFormation wizards or experts in provisioning, while still creating an architectural-driven solution, which is like a tried and tested recipe. And more importantly, that they are easy to use. Every enterprise uses naming schemes, and so does ours. It gives you a predictive naming scheme, so you can easily navigate through the AWS console if you need to do troubleshooting or just browse through your account for your application. It makes it easier for reporting, and we also created a self-service portal just based on the naming conventions we came up with. Which makes it easier for application managers to use for their day-to-day tasks without needing to navigate through the AWS console itself. We started looking into the CDK at the beginning or the end of 2019, out of more of a need for the flexibility in how we can support our teams. The first blueprints that we started out with were our serverless ones. They mostly were consisting of simple compositions between an API gateway, an authorizer, and a Lambda. But we had a hard time producing blueprints for our microservice style applications because they have a variable use cases, and they have a variable number of resources. And this is actually where CDK really offers the flexibility we're looking for. Teams can now use a mix of higher level constructs that we created or augmented based upon the ones that the AWS CDK library gives us. So what did we make for our teams? We created a C# library which teams can consume as either a NuGet package or a Git submodule. It comes with some opinions on the naming schemes and the compositions that can be used, and it offers some smart defaults. Using factories and builders, we are for creating our constructs, and providers for retrieving existing resources like VPCs, security groups, or subnets. Clusters, basically everything we pre-provisioned in our landing zones. We have classes and interfaces which can be extended as extension points to make our constructs environment aware. And a lot of organizational constants and enumerations in easy to use classes. So no more sloppy pasting conventions anymore. Most of our blueprints contain a lot of resources. Getting the naming right forces us to do a lot of sloppy pasting action between the templates, and making changes around the conventions and propagating them through our blueprints takes a lot of effort, and it's not a very dry way of working. Our CDK equivalent, however, makes use of environment aware, is environment aware and uses typed enumerations. This makes changing conventions easier, and it also has helped us implement feature branching with isolated resources just by injecting the feature branch name into the resource name. Like Tim said, some of our blueprints we call Uber blueprints because they can be used for a variant related amount of workloads depending entirely on the preset of parameters, but just being one template. Two of our blueprints have even reached the 60 parameter limit of CloudFormation. This, unfortunately, gives the end user an experience like this. They need a manual for which parameter does what and which parameter combinations can be used or cannot be used. And we would really like the experience to be more like this, easy and obvious to use. Most of our blueprints contain sensible default values and always give the user a works out-of-the-box experience. Since CloudFormation only offers default parameter values, you can only have one default per template. We started out using CDK. When we started out using the CDK, we had a lot of one-on-one conversions between our CloudFormation template and our CDK construct, and they were like mirror copies. So creating the prop objects, they were just like the parameter files, and this still gave the end user a need to know which parameter does what. And in some cases, we just want to give our blueprints a parameter set that is specific for the use case with the same construct. Luckily, now we can use various coding techniques to create more than one smart default. Using inheritance, we can let our subclasses preset certain properties for different usages within the same construct. Using factories for our prop objects or constructs themselves, we can use different methods per use case. And using factories and prop objects, using naming parameters and extension methods, we can add some more flexibility. For the more complex setups, we try to use builders because they offer a fluent API style and makes it easier to read for the bigger constructs. Using tagging conventions makes drilling down an application on all its components possible, which is essential for our cost management and making sense of our cloud bill. By adding a CI/CD tag indicating which release pipeline was responsible for creating or updating a stack, we get the traceability back to our Azure DevOps environment. And knowing which team to call at 3 a.m. when an alarm is triggered, that's on a resource, that's where we use tagging for the ownership. The last grouping, when we have multiple stacks, where when we use multiple stacks for our application using tagging, you can use the AWS resource groups to give an overview of your application and all its resources. So the lessons we've learned: creating your own library provides access to resources appropriate to the context in which they are used, therefore reduces the amount of time and reduces the amount of input needed for solutions to work, and reduces the complexity for the end user because account specifics are abstracted away in your constructs. We invite participation. So contribution and ease of use leads to innovation. While using CloudFormation on our central blueprint repository, we only got a handful of pull requests from other teams the past 3 years. Since introducing the CDK, our team has had a dramatic increase in the number of pull requests from outside of our team. Not only offering bug fixes, but a whole new constructs altogether is some of the things we have seen from even our trainees through the past year. So we like to think that offering a programming model which developers are comfortable with has added to this. And then lastly, moving from CloudFormation to blueprints, to CDK often requires redesigning, because some problems solved in CloudFormations aren't problems in CDK at all. For example, the chicken and egg problem between lambdas, triggers, and queues. And having access to looping makes creating reusable solutions less verbose, and using higher level constructs don't necessarily give you what you want. We were always trying to recreate our blueprints, and sometimes it's just easier using the CDK because the presets in the CDK are actually pretty good. Our naming, one of the things that we found, that explicit naming of resources is not the preferred way of working in the CDK, but that's something we are working on, because this is still our journey this year towards the CDK. And we're hopeful that in the next year we will also be able to get rid of all our CloudFormation blueprints and make a transition to CDK all the way with our auto-scaling groups and all other resources that we haven't yet revamped. So with that, I'd like to thank you, and I think we're opening for the QA now. Back to you, Walter.
Hi guys, thank you very much for your session. I seem to maybe possibly have gotten lost in my own platform. So I was in a place in Grip where I could see the chat that was going on, and then somehow I don't know what happened. But I lost this. Is it this one? Yeah, live chat. Okay, awesome. Yeah, so I don't currently see any questions in the live chat in Grip. At the same time, I believe that I made a mistake in scheduling and totally blew past the scheduled break that we were supposed to have from 3:30 to 3:40. So we are well ahead of schedule now, as we are. So yeah, it was an interesting session. I was wondering, so specifically with an enterprise view on CDK, I don't know if you saw the outro of the previous talk, but yeah, I'm a little concerned about the complexity as well as the power of what you can do with CDK in enterprise environments. Can can you tell me how you feel this is going at the moment?
Well, from my experience with working with the CDK, we're at the moment trying to transform our infrastructure as code offerings towards CDK, and not everything is supported in the way that we want it to be supported. And that's maybe because of a lack of understanding of the CDK on our part yet. But being in contact on GitHub, trying to ascertain if I'm doing something wrong or that something isn't supported yet, that's there you can really see that there are some aspects to the CDK that haven't developed yet, because there is a lot of churn in the code still. And it's like, how do you say, it's work in progress. You can absolutely use it for production loads, but not every resource is like on par with CloudFormation yet, or maybe in the way that we want to use it.
Yeah.
Any thoughts?
I think that the two aspects. One is that you can define something once and reuse it more easily in CDK than we could with templates. Will make a big difference. And also the variability that you don't, if you have multiple resources, you don't have to build templates that could have an option of 1 or 10 security groups rules, but that you can actually build that. You can just create them as you need them. So it actually makes me more enthusiastic to learn C# or object-oriented Python to work with creating resources in this way than with CloudFormation. And that surprised me. I did not expect that.
Yeah, okay, I could see that. It seems like quite an interesting triangle between CDK, CloudFormation, and Terraform. One of the things I've always found strong in Terraform is that because the provider is written by the open source crowd, the moment API calls become available for AWS services, the Terraform provider is never very far behind in catching up. And I believe that with CloudFormation, not every service that AWS offers has CloudFormation built in from scratch. Whereas I believe that with CDK, there's much more native support for it in the newer services. So.
Right.
Okay. Yeah, go ahead.
Oh, I agree. I agree. That makes a big difference. And so
it's this is one of the challenges as AWS grows is to make sure that this entire behemoth of services always keeps API ability at the forefront of each service. So, in my opinion, AWS should not be releasing any services that don't have API support because it's quite limiting. And you see this very clearly when you go to the more fringe services. So I've been working with Amazon Connect, for instance, and you're surprised to find out that it doesn't have any Terraform or CloudFormation templates. And I presume it also is not supported in CDK. And so the API is really now just getting off the ground, but that product has been around, or that service has been around for quite a while. And it's very strange to have to resort back to clicking around in the console because you have no other option in the AWS world where you wouldn't expect that.
Yeah, but from an enterprise point of view, one of the things that that is a first for us is like infrastructure as code. But also, if we cannot automate it and it needs to be done manually, if it's like once for an account, it's okay. But if it is something that is being offered to our teams, so it has a repetition in it, and it doesn't offer automation, then it's not something that we want to. How do you say? Tim, help me out here. It's not something that we support.
Right.
out of the bat.
Then we look for other solutions, because trying to have manual steps, especially, and even scripted, it needs to be robust scripting that you can manage out of the pipeline and not have extra steps involved in the deployment.
Yeah. So for all the stuff that we use, which there is no CloudFormation yet available, we use custom resources to do API calls within the CloudFormation. So.
Yeah, I agree with you that I discourage inside my company also the use of resources that haven't gotten an automation, a way to automate them. But with some of them, there is no way around it. For instance, Amazon Connect, it's the call center solution. Like, you can choose not to use Amazon Connect, or you can choose to do things manually. And that's it feels like a very ancient world that we've left behind quite a while ago. So, but recently they introduced more API calls, so I presume that the left over parts are still coming. But yeah, it's an interesting thing to watch over time and see how it goes. There was one question that came in probably on the back of our discussion, where someone asked, so Eugene Volko asked, is CDK and CloudFormation support different? And as far as I'm aware, they are slightly different.
What do you mean with support? As in getting support from the team?
Yeah, so he says, I thought that AWS CDK just generates a YAML AWS CloudFormation template from the code typed, but that's not the case, right? At least that's not how I understood it.
Well, that's basically how we use it. But depending on the construct that you are using, it generates a specific CloudFormation template. And the higher level you get, the more it can deviate. So if you take low-level constructs, like everything that starts with CFN, you get a one-on-one par with CloudFormation. But one of the problems we had with the REST API, you have like the higher level constructs. We always use an authorizer. So in our basic set that I told in the presentation, the simple composition of an API gateway, an application, an authorizer, and a proxy integration with a Lambda, it works flawlessly. But when implementing it in CDK for our non single page applications, it worked fine. But then we needed cores, and the core settings for the defaults, we had the default REST API. At least 2 weeks ago, it generates an options method for the authorizer as well, with the authorizer in it, and that's not something that you want when generating or using the proxy. And while we were using CloudFormation, we had more control of it, and being able to CDK, we really had to pick apart the higher level construct and break it down to accommodate our authorizer, and so that it would not have the authorizer set on the option method.
Yeah, okay, I understand. Yeah. Yeah, there's
So
a
it's a
comment
bit
from. Yeah, there's a comment from Ricardo Kustner that says CDK generates JSON templates. You can create lambdas that add some functionality beyond standard CloudFormation. For instance, to upload objects to S3 with a deploy. To be honest, I haven't used either one of them. I unfortunately don't do that much technical work anymore these days. So most of my information comes from what I see our teams do. But anyway, thank you very much for your session. We're getting back on track. I'll put in a break for people now to go and do the things they need to do in break times. And thank you very much for being with us. And I'll move to a break, and I'll be back in 10 minutes. So 10 minutes past 4, I'll be continuing with
Our pleasure, Walter.
Yeah, thank you,
Yes.
Walter. Sorry for the rough beginning, but yeah, great. Okay, thanks.
Thanks, guys. Yeah. Okay. Bye.